Okay. Now I only have about 40 tabs open that I actually need to do this effectively. But here it goes. All right. Anyway, the code for joining the pair deck is TUNFO. And you can either do it there or you can just look at the screen I'm presenting on Hangouts. Either one's fine. They're going to show the same thing. Though having it present on your screen, though, will probably be bigger so you can see the pictures and diagrams better. There is one YouTube video I'll be showing at one point in the lecture today. But it is what it is. All right. I'll move my head so you guys can see the code. All right. I'm going to go ahead and start so we have time to get through all of it. But we left off on Tuesday talking about nuclear energy. We never talked about nuclear energy. And nuclear energy is our last non-renewable resource. It is not a fossil fuel. Nuclear energy comes from elements like uranium or polonium or plutonium that are that radioactively decay and produce heat. Okay, and you'll have to know about the advantages and disadvantages. The first major advantage, though, of it is that it does not create CO2 pollution. Right? It does not. There's no. When you see a nuclear power plant, the smoke coming out of a smokestack there is all water. It's all water vapor. It's steam. So, as far as the atmosphere is concerned, nuclear does not contribute to atmospheric pollution at all. All right. So that's its big advantage that is going to probably make it become more common in the 21st century. All right. So again, we'll talk about that. I want to just double check here that I am recording. Am I recording? I hope I'm recording. I think I'm recording. I'm recording. All right, we're good. Okay. So nuclear reactors generate electricity with nuclear fission. Fission is the breakdown of a larger atom. That's why when I was listing off radioactive elements earlier, these are all elements that have a large nucleus. They're closer to the bottom on the periodic table, and when they decay, they will lose protons and neutrons and turn into different atoms. Actually, so like uranium, when it radioactively decays, it becomes lead because it loses protons, and so it moves its atomic number changes. Okay. So fission here is a nuclear reaction in which a neutron strikes a relatively large atomic nucleus. It then splits into two or more parts, releasing additional neutrons and energy in the form of heat. All right. So you use this heat to boil water and spin a turbine, just like any of the other types of electricity generation we've looked at so far. Okay. So uranium-235 is the most common. That 235 there is just the size of the uranium atom. All right, that's 92 protons, and the rest of them are neutrons in that number. Okay, so here's kind of a picture of what it looks like. You have your uranium-235, and when a neutron hits it, it breaks into two smaller atoms. It also releases a few neutrons that will trigger other atoms to decay in this way, and it causes a chain reaction. All right, and if you hear about meltdown, that means this chain reaction happened in a way that these atoms started breaking exponentially, and the heat gets out of control. Right, and this happens when all safety features fail at a nuclear power plant, which is what we saw in Japan when an earthquake and a tsunami caused a lot of the safety features of a nuclear power plant to fail. It's what happened in Chernobyl, but Chernobyl was more of a result of experimentation and intentionally turning off safety systems. The Soviets were doing testing on it they shouldn't have, right? And it caused it to melt down and explode. All right. A fuel rod are cylindrical tubes that encase the nuclear fuel in a reactor, and a control rod is inserted between them to absorb excess neutrons, and stop the fission reaction. Okay, it keeps it keeps everything safe. And there's lots of other safety features that keep them cooler. And in general, today nuclear power plants are safer than they've ever been. That said, the ones in Fukushima were considered fairly safe. But what's safe when a magnitude 9 earthquake hits it? It's hard to plan for these things. A magnitude 9 earthquake is shaking like you can't even comprehend. All right. So remember, the big advantage of nuclear is no air pollution, right? It only releases water vapor. It does not release CO2. It does not contribute to climate change. It does not contribute to atmospheric warming. And there's no need to import oil. In fact, in America, we have all the uranium we'll ever need. All right. There's lots of uranium deposits in the West, and we would never need to import any of it. All right. Disadvantages, though, you probably already knew before you came in here, that nuclear has the possibility to create accidents, and the accidents with nuclear can be pretty bad, and it makes it so that you can't ever move back to some of these places. The area around the Fukushima power plant will not be inhabitable for thousands of years. The area around Chernobyl won't be habitable for thousands of years. In fact, our cultural memory of what happened at Chernobyl will be gone before people will be allowed to colonize it again. So there's actually an interesting thought problem that people have come up with. How do you warn future generations about what happened at Chernobyl when it's hard to say what the future will look like thousands of years from now and may not speak our languages? And, so it's an interesting thought problem that the people actually are actively discussing, because we don't really know how to tell someone 10,000 years in the future, hey, you can't live here because it's radioactive, right? Chernobyl won't be habitable for 100,000 years, all right, because the accidents there make the ground radioactive. Okay. It's also hard to get rid of radioactive waste. Right now, our solution is to encase it in large lead and concrete boxes and bury it in the Nevada desert. We picked the Nevada desert because, first of all, nobody lives there. And second of all, it's not along any major watershed. In fact, the Nevada desert is so dry that it doesn't flow anywhere. In fact, water will just flow down a mountain and then evaporate. There's a lot of just micro watersheds in there that end in salt deposits. All right, so it's not a bad place to put it when it comes to having to choose where to put something awful. All right, and there's concern about the nuclear material being misused. Right, one of the we see this, with countries like Iran and the questions about what they're actually doing with their nuclear capabilities. Are they actually using it to produce electricity, or are they using it to make weapons that they probably can't be trusted with? Okay, so these are all concerns, and you probably knew about them because nuclear makes the news, right? Even though accidents at coal-fired power plants and accidents at petroleum power plants can cause just as much hardship to human life as nuclear does. You don't hear about it as much because it's just not as attention-getting as nuclear is. We have this fear of nuclear just kind of in our culture, and so when we hear something about it, it makes the news, and it's something that people make a bigger deal about. All right. Radioactive waste is nuclear fuel that can no longer produce enough heat to be useful in a power plant, but continues to emit radioactivity. All right, so it's still radioactive. It just doesn't produce heat. You guys that watched, has anyone finished watching the video yet? Did any of you guys see? Did any of you guys see what happened? What France does with their radioactive waste? Anyone catch that?
Yeah, it was really good.
Yeah, they reuse it. They're able to re-enrich it. So it involves putting it back in a centrifuge and re-enriching it. And you end up with, in the end, after you've reused it a bunch of times, you have a nickel size worth of waste for, what is it? I forget what it was. It's like 1 million people per year or something. It's really effective to do it that way. The reason why American power plants don't do this is because it's more cost effective to just go mine more uranium, right? And in France, the the power grid is it's basically socialized. It's run by the government mostly, and they have made getting rid of the radioactive waste a priority that they're willing to spend money on. Right, and so they produce lots of relatively clean energy, like we'll call nuclear clean energy in quotes here, and they're able to do that because they reuse pretty much all of the waste. Right, and what waste they do have, they're able to store safely for a long time without having too big of a footprint. All right. These two units here are just units that measure radioactive decay. I don't think I've ever asked a test question on them, so I don't think you got to worry about those. All right. High-level radioactive waste comes from used fuel rods. Low-level radioactive waste is found in things like protective clothing, tools and rags, and other items that are used in plant maintenance. Right. So Marie Curie is the scientist that kind of helped us understand radiation and radioactive material, and her clothing is still radioactive. Right, you actually can't touch it because it's considered radioactive waste, and it's pretty intense radioactive waste because in the years that she was working with it, we didn't really understand it, and so she did not take the precautions that one would today working with some of these things. All right. Uranium mine tailings and the residue left over is also radioactive. And every step along the way, disposal has to be handled with care. All right. You can't just let radioactive stuff sit around because it makes other things radioactive. All right. The neutrons will smash into other atoms and then they'll decay as well. All right. So that's the big challenge with nuclear is what to do with the waste when it's done. All right. So that was our last of our non-renewable resources. I mean, if you want, my opinion there, I think that nuclear is probably one of the better ways to go in the future because it can actually supply the volume that we will need without causing the atmospheric damage that fossil fuels use. And I think that what issues we do have are easier to overcome than the issues with a lot of other types of electricity that you'll see here as we talk about sustainability and renewable resources. Okay, but the big topic of chapter 13 is not just non-renewable resources. It's also like how to be more energy efficient in the first place. Okay, those of you guys that have just joined, the code to join is up here at the top right corner of the screen. I'm presenting, so if you want to have Pear Deck open, you can. I'm also recording this right now, so I will post the recording later today. That in case you missed the first part of this, where we talked about nuclear. Now we're talking about energy sustainability and what things that we can do to make the U.S. and the world more energy sustainable in the future, because energy use is kind of our biggest impact on the environment right now. All right. So all we're going to be talking about here are strategies to conserve energy and then differences among the various types of renewable energy sources. All right. And every one of the renewable energy sources comes with its trade-offs. Okay. There's no perfect energy source. Otherwise we'd be using it. Every single one has issues that we're going to talk about. All right. Energy conservation, energy efficiency are the least expensive and most environmentally sound options for maximizing resources. What does this mean? This means that any step that you take to just reduce your impact is better than like trying to find some alternative energy source, right? So energy conservation is just finding and implementing ways to use less energy. And one way that this has been attempted is with a tiered rate billing system. And it's where consumers pay higher rates as their use goes up. All right. So right now we all pay 11 or 12 cents per megawatt hour, maybe 10 cents here. It's actually a little cheaper here in Ohio. And a tiered rate system would mean if you are like, let's say you run a factory that's using 10 times or 100 times the amount that a normal house does, the power company would charge you maybe 15 cents or 20 cents per megawatt hour. So these companies would be forced to look for more ways of making themselves energy efficient. Right? Sorry, I am at school. That's what the bell is. Peak demand is the greatest quantity of energy that is used at one time. That's usually at a certain point in the middle of the day when everybody's got everything on and your drain on the electric grid is the highest. Sustainable design. If you're going to write this down, I would say wait till the next slide when you can look at the picture. Sustainable design improves the efficiency of buildings. And that's without like making major changes to anything. So sustainable design, you're reducing your footprint, not by like installing solar panels, like switching energy sources. You're reducing your impact just by making little changes here and there that just reduce the amount of energy that the building uses, right? And you'll see what I'm talking about here on the next slide. So this house here is an example of an energy efficient home. And some of the things that you can see here are skylights that can help improve the heating in the winter, a shade tree, which helps make it cooler in the summer. And these, you see insulation here that just reduces the amount of heat loss to the environment. High efficiency windows, again, they're insulated, that keeps whatever temperature you want inside. Notice for at least homes, most of the energy efficiency systems are related around heating and cooling because that's where most of our energy is used, right? That's why your dad always freaks out about the thermostat, right? Because most of the money that we spend on energy, we spend heating and cooling our homes. Okay. So, well, actually, let's go back here. I'll let you guys write this down. Sustainable design improves the efficiency of buildings where communities in which we live and work. And I don't know why we's on there twice. My fault. All right, I'll give you a second to write that down before I go on to the next one. You got a lot of new faces on the lecture today, guys. Welcome. Yes, I'm wearing my jersey in honor of Spirit Week. All right, for those of you who just joined in. Don't know if we'll have a college football season this year, but let's hope, right? Okay. Passive solar design is a way to take advantage of solar energy without using active technologies, without using like photovoltaic cells or something. So you can take advantage of heat from the sun without actually buying a solar cell. All right, and I'll show you what we mean by this in a minute. And thermal mass is the property of any material that allows it to stay cold or hot, right? A sheet of aluminum is going to have a low thermal mass because it's going to change temperature with whatever the environment's doing and change quickly, right? Things like wood hold on to the temperature a lot better, right? And it's harder to change. Water also has a really high thermal mass. Okay. So passive solar energy can lower your electricity bill without the need for pumps or other mechanical devices. Some examples of how to do this are building a house or building windows along south-facing walls. And that south-facing walls is where you would build them if you live in the northern hemisphere. If you live in the southern hemisphere, you'd want them on north-facing walls. But regardless, if you have windows on a south-facing wall, what that does is during the winter, when the sun stays in the south, your house will act kind of like a greenhouse because the rays coming in will heat up your house and it causes you to just run the thermostat or run the furnace less, right? So just doing that would reduce your lifetime energy consumption and save you money in the long run. Okay. So here's an example of it. Notice that in the winter, the sun is at a lower angle. And so the light's coming in this window, hitting a heat absorbing floor, going through an insulated window, and that's going to heat up the room. In the summer, you have these overhangs here that protect when the sun is highest in the day, creating most heat. These overhangs keep the house shady and keep the sun from coming in and heating up the house. So it helps your cooling as well. So just something as simple as designing the front of your house like this can reduce energy. Sorry, guys. My phone's ringing. All right. So I think this is cool. I would maybe draw a picture of that in your notes or something because I like to talk about this and like to ask questions about it. All right. Also, notice here this heat absorbing floor. That means the building materials were specifically chosen for their heat retaining properties. Okay. Now you wouldn't want that if the light's going to be blasting in on your floor in the summer. So you have things like window shades and overhangs to help reduce the amount of light coming in the summer as well. All right. Okay. Renewable energy comes in two flavors. You have potentially renewable and non-depletable. All right. Potentially renewable is an energy source that can be regenerated indefinitely as long as it's not over harvested. This would be things like wood. Okay. Wood is a potentially renewable resource, but you also can exhaust it if you cut down all the trees. Okay. Non-depletable is an energy source that can't be used up. This would be things like solar energy. You can't ever deplete solar energy because you can't deplete the sun by making solar cells. All right. And renewable is just any energy source that is potentially renewable or non-depletable. Okay, as far as its share of our energy use goes, renewable energy makes up about 13% of, what is this? Is this worldwide? Yeah, this is global energy use, right? And of that, most of this is combustible renewables, so using things like solid biomass or ethanol fuels, those kinds of things, wood, all right. And then smaller fractions still would be things like solar, wind, geothermal, and hydroelectric. And if there's anything that has changed in recent years, like since this was published, it would be these figures, all right? Solar, wind, and geothermal have been taking bigger shares of this pie each year, especially in the last, I'd say 5 years. The cost of solar has gone down significantly. All right, there have been improvements in that technology, and the cost to create a solar panel is a lot lower than what it used to be. And so solar energy is becoming, like photovoltaic cell energy is becoming a lot more of an option than what it was in the past. All right. In the United States, as far as our renewable energy goes, biomass is about 49% of the energy we're using. And these are people that are using like wood burning stoves in their homes and that kind of thing, or ethanol, corn ethanol fuel in their cars, things like that. All right. Hydroelectric, a lot of our electricity comes from hydroelectric. This is a lot more prevalent in the West, like in Oregon and Washington. It's also more common in the South, especially along the Tennessee River, where hydroelectric dams were installed as part of the New Deal, and where the government built lots of dams to just put people to work in the 30s when we were in a depression. Okay. Wind was 15% in 2012 when this was made, but that is definitely higher now than what it was. All right. Wind farms have been going in all over the place since then. So expect this number to be higher, the percentage of wind. All right. Geothermal is mostly used for heating and cooling, and that is becoming more common as well. A lot of people that are building houses build them with a geothermal system just put in place because it's a lot cheaper to heat and cool your house with geothermal. And it's pretty easy too. You only run one small electric pump and that's it. All right. And solar was 3% then, and also this would be taking a bigger chunk of the pie these days as well. All right. But notice it is only 7% of our energy in the United States. Again, it's higher now. I don't know exactly, 8 or 9, something like that. But it is creeping up and taking up more of the share of our energy usage. All right. So biomass and water energy are going to be the first ones we talk about. Biomass is using things like wood and manure and other things that can be combusted. This slide here, though, is just showing that the sun is pretty much the source of like nearly all the energy that we use other than nuclear, right? The sun grows plants, which we can use as biomass or use in the form of fossil fuels. It's just the sun's energy that was captured millions of years ago. The sun also drives weather cycles, so wind and hydroelectric are essentially solar energy. And residential geothermal is from the sun. Natural gas decayed ancient plant matter. So again, the energy came from the sun, right? With most energy, pretty much anything that you do during the day, from like anytime you move your body to anytime you like turn on a light, you should be able to trace that energy back to the sun, right? The only exception to that would be if your electricity comes from nuclear, that energy actually comes from radioactive material, which you could argue got its energy from the Big Bang. So we're not using any solar energy there. Nuclear. Also, tidal energy is one thing that is becoming more viable these days, which relies on the gravitational pull of the moon and not the sun as much. All right, biofuel are liquid fuels created from refining biomass. This would be corn ethanol. Right, if you drive by a gas station and see that it is selling E85, all right, that is ethanol that is just from refining corn, and it's essentially alcohol. Ethanol is the type of alcohol that is made, that all like alcoholic beverages are made of. Vodka is almost entirely ethanol. All right, and it burns well, and so you can be used as a fuel for a car. Okay, so there's some controversy there as to whether we should really be using food for fuel, but we produce so much corn in this country that that's hardly a controversy, in my opinion. All right, sorry, my phone's going off. All right, we call this type of fuel modern carbon. It means the carbon that you're releasing into the atmosphere from burning biomass was just recently in the atmosphere. So if you're burning corn, right, that corn got its carbon from the atmosphere within that year, right? So it's considered modern carbon. If you're burning fossil fuels, though, you're releasing carbon into the atmosphere that hasn't been in the atmosphere for hundreds of millions of years. All right, so that's considered fossil carbon. Any activity that does not change CO2 concentrations in the atmosphere is considered carbon neutral. And so, like, burning biomass is considered carbon neutral because that carbon was just taken from the atmosphere that year. Okay. Although there's probably no such thing as a true carbon neutral activity. Idealistically, that's what it would mean. So the CO2 that you're putting into the atmosphere had just recently come out of the atmosphere. So you're not changing the content. If you're burning fossil fuels, though, you are, because that carbon in fossil fuels hasn't been in the atmosphere for 300 million years, roughly. Solid biomass, that's anything like wood, charcoal, manure, etc. These things were used to heat homes throughout the world and was essentially our primary energy source up until 1875, and is still the primary energy source in a lot of the developing world. Okay, and in the developing world, people often can't afford fossil fuels, and so they're doing subsistence energy use. They're going out and collecting biomass every day, or they're making charcoal. All right. Net removal here would be the process of removing more than is replaced by growth, typically used when referring to carbon. In your book, at the beginning of this chapter, I believe, so chapter 13, it shows an aerial photograph of the line between Haiti and the Dominican Republic. All right, so if you don't know about the geography of those two, Haiti and the Dominican Republic share an island. All right, and there's just kind of like this line that's drawn like along the eastern third, where on the western side it's Haiti, on the eastern side it's the Dominican Republic. And in Haiti, there's a lot more subsistence energy use, and they have almost no trees on their side of the border. All right, or if they do, they're really young, small trees. And the reason why is because they still rely a lot on charcoal to heat their homes and to cook their food. And so charcoal, producing and selling charcoal is a viable business in Haiti. And so people will go up into the hills, right up to the very border with the Dominican Republic, cut down the trees, turn it into charcoal, and sell it. All right. And they've pretty much depleted that stock. All right. So the net removal, there was more than is replaced by growth. You would say there's high net removal of charcoal trees in Haiti. Solid biomass is the use of wood. Obviously, it's unsustainable if you are harvesting it from a forest faster than the forest can grow. That's pretty obvious. Okay. Charcoal is lighter than wood and contains twice as much energy and produces less smoke. That's why it's kind of a preferred fuel. it does require energy to make charcoal, but a lot of places it is still a primary way of heating homes and cooking food. Right? In regions where wood is scarce, people often use dried animal manure as fuel for indoor heating and cooking. Obviously, burning manure is going to create indoor air pollution, which I think we probably already knew. Biofuels, things like ethanol and biodiesel. Liquid biofuels can be a substitute for gasoline or diesel fuel. Again, like I've said, ethanol alcohol can be made by converting starches and sugars into alcohol. All right. This is the same process that you would use to make moonshine, all right, or whiskey or anything like that. It's the same process, right? It's just rather than drinking it, you're using it as a fuel. Okay. Biodiesel. So most cars that run on diesel or vehicles that run on diesel fuels are really it's thicker, it's oilier. And diesel engines are essentially less picky as to what combustible material you're putting in there. And so different types of vegetable oils can be used to make diesel rather than petroleum. And so biodiesel is something where you basically are using vegetable oils to make diesel fuel. There are some diesel engines that can run on oil from a French fryer, right? And so people that have these engines will actually go to McDonald's and say, hey, can I have your French fry oil that you're going to throw out? And they'll actually put it in their diesel engine, right? Now, a regular diesel engine can't do that. It's got to be specifically made for that kind of thing, but it is possible. All right. Flex fuel vehicles were more common a few years ago than they are now, but they're vehicles that can run on gasoline or gasoline ethanol mixture. So probably more 5, 6, 10 years ago, you would see signs up that said E85, and you'd have cars that run on it. Right? It's becoming less common because E85 has kind of fallen out of vogue as it's become a little more controversial with the idea of turning food into fuel. All right, next one's hydroelectricity. So if you're taking notes by pen, I'd draw a line here. All right, we're talking about hydroelectricity now. Again, it's renewable. The sun is the driving force behind it. And these are basically 4 flavors of hydroelectric power, or 3 flavors. Hydroelectricity is any electricity generated by the kinetic energy of water. The first one would be run of the river, where you're not making a dam, you're just, or maybe just a small one, and it's turning some kind of turbine that produces electricity, right? I'm really into backpacking, and one of the things that always gets advertised to me, on any online platform I go onto, are these run of the river fan turbines that you can just throw in a river, and it produces enough electricity to charge your phone. Okay, they exist. These were more common 100 years ago, run of the river power, but rather than generate electricity with it, they would use it to run a mill or a factory. All right, they would turn a big wheel that would in turn turn smaller gears inside, and you can run a sawmill with it. You could run a grain mill with it. You could run lots of things with just this energy from moving water. All right. Water impoundment is where you store water in a reservoir behind a dam. Obviously, if you do that, the electricity that you generate from it is a lot more consistent because you can control the flow coming in and out of the dam. All right. Tidal energy is energy that comes from the movement of water generated by the moon. To give you an idea of how that works, I posted a YouTube video here. Hopefully this works. All right, can you guys see the YouTube video pulling up on the Hangouts?
Writing's not that easy, but Grammarly can help. This sentence is grammatically correct.
Can you guys see this? So here's the concept. Here's the waves move. It turns these buoys up and down, and those in turn are going to be running small magneto turbines inside. So it'll show you. All right, so every time a wave goes through, it's generating some electricity. And it's going to show you how here. All right. So these are going to be giant magnets, right, that are going to be surrounded by copper coils. that's going to create some electric motion. Okay. All right. So the point of that was just to show how you can capture energy from waves. All right. It is possible. And at the end there, it says if you capture 0.1% of the ocean's energy, then we would be able to power, all human energy needs 5 times over. That's true, but 0.1% of the ocean's energy is a ton of energy, and you'd have to have those things everywhere to capture even 0.1% of the ocean's energy. That is a lot of energy to try to capture. All right. So here's how a hydroelectric dam works. You usually have a reservoir. You always have a reservoir behind it. And as the water flows in down the pipes near the bottom, it's going to spin a turbine, because the more water you have behind it, the faster that water is going to move, the faster those turbines are going to spin. And that's going to create a lot of electricity that gets sent out through transmission lines, just like any other power plant. And essentially, again, the goal of generating electricity is, how do you make a turbine spin? Okay. If you can come up with a way to make a turbine spin, you can come up with a way to generate electricity. All right. Hydroelectric has lots of benefits. It obviously doesn't create air pollution or CO2 emissions. It's also cheap, and reservoirs are fun. All right. Everywhere someone's put in a reservoir, there's, people put in campgrounds and boat ramps and lots of other things that people like to do with rivers. All right. So generally they are good for the local economy to put in a reservoir. All right. And last year I had my students read a case study where in China, they put in the biggest hydroelectric dam in the world by damming up the 3rd largest river in the world. And to do that, though, they had to create a lake that covered lots of ancient ruins and displaced tens of thousands, hundreds of thousands of people. Like, they all had to move somewhere else. All right. And we had to discuss the pros and cons of that approach. Is that an okay way to harvest energy? All right. Even if it comes at great costs. All right. And so the reason why I tell you this story is because the point of all this is to show you that no energy source has all the answers, right? Can solve all of our problems, right? Because as you see, there are drawbacks here. Some of the negative consequences: the reservoir will flood permanently agricultural areas or places of archaeological significance, or force people to move. Impounding a river can interfere with the organisms that depend on free-flowing river, right? Lots of fish depend on rapids to lay their eggs. And if they have to try to lay their eggs in a giant lake, they won't, all right? And so that will cause the species to just leave, because it'll move outside of their range of tolerance, right? Obviously, downstream ecosystems are going to be affected. And the dam will also hold on to large amounts of sediment, which can be good sometimes, but also, like, there are places that depend on those sediments downstream to provide nutrients. And so that's another issue of hydroelectricity. All right, module 39, and I think this is our last one. No, it's not. There's 2 more. All right, module 39 is solar, wind, and geothermal, and hydrogen. These are kind of the big up and comers. All right, a lot of newer ways to produce energy rely heavily on these things. And these are kind of the idealistic ones that everybody likes. But then when it comes time to implement them, you realize right away there's issues with it. All right. So here's a map of the United States that shows variation in solar radiation. All right. And one thing you'll notice right away, that here in cloudy Ohio, you can't really get a lot of energy from wind. from solar, because the sun just doesn't shine very much. All right. First of all, we're at a high latitude, and so the sun strikes at an oblique angle for a lot of the year. And then also, it's just not sunny very often. And so solar cells, we call them photovoltaic cells, they are not a real viable option here. Yes, you could still profit off of them here. It will take you a lot longer of a time to recover the cost that you spent on them here than it would if you installed them, say, in southern Arizona, where, as you can see, they get a lot more kilowatt hours per square meter per day of energy. All right. So where you can use solar effectively varies a ton by geography. All right. This is considered active solar technology. If you see this word here down on the middle of the page, it says photovoltaic solar cell. That's just, that by its street name, solar panel, right? Any black rectangle used to absorb sunlight and generate electricity is a photovoltaic cell, right? But definitely know that word, photovoltaic. And if you see the abbreviation PE, when talking about this, that's talking about photovoltaic energy, right? Or if you see just PC, that's photovoltaic cell, right? They do get abbreviated. Okay. Other technologies that employ solar energy are solar water heating systems, where they will use the sun to heat up water that will be used in radiators and things. And these photovoltaic cells will, collect photons and turn it into electricity. There's another way of using solar for energy, though, and that is these the last bullet point on the list here, these large-scale concentrating solar thermal systems. I don't know if there's a picture of one on here. I don't see one. There was one in the video. Those of you watched it, did you guys see the solar concentrating system in Spain? It was.
Yeah.
All right. What do they do there?
What was the question?
What did they do in Spain with the solar energy?
They use a bunch of mirrors and then they shine them all on this one thing.
Yeah. So you have like a giant array of mirrors that all are pointing in the same spot. All right. So as the sun is overhead, all right, all of these mirrors are going to focus the light on one thing. All right. And the one thing they're focusing their light on can boil water and drive a turbine. All right. And so that's another way of using solar energy without running a photovoltaic cell. Right? It requires mirrors and it requires the movement of water. All right. But again, these are non-polluting. They're great. Obviously there's no CO2, but they don't work all the time. And during peak demand time, if you're using solar, you have to have probably some kind of fossil fuel backup to keep it going. All right. During peak demand, you're probably not going to produce enough energy through photovoltaics to supply the energy you need. You would have to have a natural gas plant running at the same time or a nuclear plant running at the same time. All right. To supply the energy needs. Okay. Photovoltaic is maybe less expensive than running like electrical transmission lines to some homes. So if houses are really far out, it might be better to have photovoltaic system running that on its own circuit. Here in Ohio, if you install solar panels on your home, most of the time, if you cover your roof with them, you'll produce more electricity than you need most of the time, right? And if you do that, the power company will actually buy the energy back from you, right? So they sell you the energy at 11 cents per kilowatt hour. They probably buy it off you for about 6 cents per kilowatt hour. But if you're producing it, you'll get a check from the power company. And a lot of people think that having solar panels will be great if the power goes out. The problem is if the power goes out, they make you turn your solar panels off. And here's why. Because your solar panels will actually be flooding the grid with energy. Line workers that go up there to try to fix the power lines that are broken that caused the power outage in the first place, are planning on those not having energy to them, and so if your house is sitting there pumping current into those, you could endanger the lives of the line workers. All right. So if you are running that, they will call you and have you turn your solar system off if there's an outage in your area. All right. Some more drawbacks. Photovoltaic panels are expensive. Okay. It takes a long time. So if you're going to install photovoltaic cells on your house, it will be a while before you recover that cost. Okay. You'll spend thousands of dollars, maybe $10,000, $20,000 installing these on your house. But, over time, give it 15, 20 years, you will recover that cost. It just takes a long time. Now, you will recover that time faster if you live in Arizona. All right. But here in Ohio, it could take a long time before you recover it. Okay. The manufacture of them is not a nice process either. There's lots of toxic metals in them. They all have to be mined from somewhere. Those mining operations, as you know, are not usually environmentally friendly. Also, these systems typically require batteries. Batteries require lithium, which also has to be mined from somewhere. And lithium mines are not great for the environment also. All right. And then trying to figure out what to do with them when you're done with them. The end of life recycling is also another environmental issue that you have to deal with. All right. So people in the past have told me that this unit is depressing because every time we talk about what could potentially be a solution for our energy needs, it turns out there's a lot of drawbacks to them. And these are the drawbacks for solar. Solar is not immune to drawbacks. Wind energy is great. All right. You have giant turbines. It's the fastest growing source of energy in the world. Just in my lifetime, I've seen wind turbines pop up in places on huge scales that were never there before. Has anyone ever driven to Chicago via Route 33 to the northwest? If you have, you've driven through huge fields of wind farms, right? Those are particularly windy places because it's on really flat land. Also, you get a lot of wind coming off the Great Lakes there. And so that they're great places for wind energy, and pretty much anywhere where they experience high winds, they put turbines in. They put them on the tops of mountains because high mountains get high winds. They've also put them in lakes and on coastlines because the edges of lakes and oceans also get high winds. Still at school. All right, so this is wind energy per country. United States, and this is back in 2012 or 2013 that the United States was producing a lot worldwide. But as far as percentage goes, Denmark wins that. They have installed wind turbines all over their country and also out at sea. All right, Denmark sits in the North Sea, which is very shallow, and so it's easy to install wind turbines out in the water. And they get, as you can see, more than a quarter of their energy from wind. And you saw that in the documentary if you watched it. All right, it talked about Denmark and their wind use. Okay. This number, though, the percentage of energy used by wind in the U.S. is going up because we are still installing these. Okay. So wind turbine are just turbines that convert wind energy into electricity. Okay. The wind transfers energy to a gearbox, which transfers it to a generator. Okay. Wind turbines are typically installed in rural locations away from buildings and population centers. They're grouped in wind farms. The reason why no one really wants to live by a wind turbine, they are loud and they're not very pretty and they kill birds, and all those things tend to bother people. All right. So yeah, it's the same diagrams just like we've seen all over the place, where you have something spinning that is going to spin a magnet inside copper coils. That's what the generator is. The generator is going to be full of copper coils, and the middle is going to be on a magnet that spins. All right. So obviously, advantages of wind energy is it is non-depletable. It's free. Okay. After you make and install it, you almost have to do nothing with it. Okay, it just keeps going. All right. Um, no pollution, no greenhouse gases, and they can share land with other things. So if you want to just supplement your, let's say, natural gas power plant with wind energy, you can, because you can just install turbines all around it, with no additional footprint. Okay. The disadvantages are off-grid wind systems rely on batteries to store them. Batteries, again, require the mining of elements that have their own set of environmental problems. Okay. Wind turbines are loud. I don't know how they get this number, but there's estimates that 40,000 birds a year are killed by turbine blades. And these are often like beautiful birds that people like. So like birds of prey, like eagles, get killed by them because eagles are big and they don't look up. Okay. They have no reason to. Eagles always look down because they're looking for something to eat. They never have to look up because nothing's ever trying to kill them. Okay. And so by not looking up, they miss giant blades that are coming towards them. Okay. And the grounds around wind turbines can be littered with dead birds sometimes. Right. Because they get moving really fast and people and birds can't see them coming. Also, as far as disadvantages go, again, it's dependent on whether or not there's wind. If there's no wind energy. Okay. And so you have to supplement wind with something else. There would have to be some other power plant nearby supplying that peak demand, supplying that energy for when it's not there. That would have to be going. All right. Wind by itself will probably never be the solution because it's just not windy all the time. All right. Geothermal is another non-depletable source. The Earth has a lot of heat inside it. All right. And you can get that directly. Anyone remember what country from the documentary relied on this almost entirely for their electricity? Did you guys catch that? What country used
Iceland.
geothermal? Yeah, Iceland. All right. So Iceland is on a divergent plate boundary. All right. Spreading center, and where that is happening, the crust is thin. Lava comes closer to the surface. And so anytime you get water down in that, you're going to get a lot of steam energy, and you just put a power plant right where that's happening, and you can use that steam to power a turbine and generate electricity. Okay. And we have our own geothermal systems here in the U.S. that we could use. They're out in Wyoming, around where Yellowstone is. Also up through that whole northern Rockies, you get some geothermal activity. All right. China and Iceland also have big geothermal reserves. Also Russia, which I don't know why it didn't make the list there. All right. Ground source heat pumps. These would be, if you've ever seen someone's house where they say that it's powered by geothermal, it's heated by geothermal. This is where they have actually buried a coil in their yard that can be used to transfer energy inside the house or out from the house, just with the use of a heat pump and some radiators. Okay. Again, they call it geothermal, but this actually comes from solar energy, because in the summer or in the winter, you're using ground that has been heated up by the sun, and just water continues to collect that energy and moves it into your house. And it's shallow, and so it's more of the sun's energy than it is the deep geothermal stuff. All right. So this is an example of how they work. All right. You have a compressor and a radiator. And if you push water out of the house and underground, have it come back in, that's going to generate heat inside the house. And if you flow it the other way, it'll cool your house. All right. They use a lot less energy than traditional furnaces. A buddy of mine used one of these for heating his barn, and I was amazed how hot it got in the dead of winter. All right. These really do work. And I'm going to be honest, I do not quite understand how it works. But it does. Bury coils. They pick up enough thermal energy that they can heat up a large area. And all you have to do is power the pump that moves the water around. You don't have to apply any energy to heat it. Okay. Hydrogen fuel cells you use in cars. right? They require the process of electrolysis to work. Electrolysis is what happens if you put an electrode in water and you run it. The electricity will separate water into hydrogen and oxygen, right? And it will also do it in a perfect ratio so that it explodes with the most efficiency. So namely 2-to-1 hydrogen to oxygen ratio. And as you run an electric current, it's going to separate those. Obviously, the hydrogen can explode after that. If you've ever seen that experiment done, if you haven't, you'll see it in the first chem class you take in college, where they take a hydrogen balloon that's filled with 2 parts hydrogen and 1 part oxygen. They'll spark it, it explodes, and it creates tons of heat. It releases energy. Your byproduct is water vapor, but it never creates as much energy as it took to separate the hydrogen and oxygen because of the second law of thermodynamics. Okay, and you're always going to lose energy along the way. But if you can come up with a clean way of separating hydrogen and oxygen, you now have a more explosive fuel you can take around. And so this is why it's good for cars, because cars need explosive fuel off the grid all the time. All right. So here's an example of a fuel cell. It requires a hydrogen tank that is going to pump elemental hydrogen into an electrode. All right. And those will separate. The protons will then flow into a reaction layer where it's going to react with oxygen. And that reaction is going to cause the flow of electrons from one end to the other. That flow of electrons is electricity. And so it's an electric car that runs on hydrogen as the fuel source. Again, the energy it takes to make the elemental hydrogen is going to be more than the car gives back. But if you can generate the hydrogen in a clean way, then this is a pretty good way of making cars that run without polluting the atmosphere. Okay. So these are hydrogen fuel cells. This is a learning target. It could potentially be on the test. I'm going to say on your test, though, I'm going to probably say it's not as likely as other things. All right. Module 40 is our energy future. This is what you guys are going to write about, probably starting next week. I'm going to have you guys come up with a plan for transitioning Ohio into a more sustainable energy producer. And these are going to be some of the things that I want you to focus on. So like I've been saying here, if you haven't picked it up yet, here it is in black and white, or blue rather. No single energy can replace the non-renewable energy resources in a way that is completely renewable, non-polluting, and free of impacts from the environment. All right? Let me say that again. There is no replacement for fossil fuels that doesn't impact the environment. Anytime you use electricity, you're going to be impacting it in some way, no matter what source you use. Right? So, sustainable energy has to include energy efficiency, energy conservation, and using a mixture of renewable and non-renewable resources in a favorable way. All right. So if you focus all your attention on just what renewable resource can we use, you're going to miss the bigger picture as to what we actually need to do to reduce our energy consumption. And if you watch that video, you pick that up, right? They spend a lot of time talking about that. Okay. So when you write about this, you're going to be focusing on all parts of it. Okay. Sustainable energy must consider the costs, benefits, and limitations of each energy source. Convenience, reliability, and logistical considerations are also important. For example, you would not use solar as your solution for electricity in Ohio, right? Because you just cannot make enough solar cells to make that reasonable for the string of 120 cloudy days that we have a year in Columbus. Okay. Also implementing smart grid technologies. These are, just employing computers and programming to, accept whatever source of energy it can and distribute it to end users in a way that is efficient and, takes into consideration peak demand for different areas at different parts of the day. All right. And a smart grid is going to optimize the use of energy in a home while continuously coordinating with energy availability. So that's essentially computers that are going to determine when and how the best way of getting energy to your home is. All right. That are going to be talking back to a central location also. All right. That's the end of the lecture, guys, which we are right on time. Does anyone have any questions about anything or want me to go back to a slide real quick and explain something for your own notes?
When are we going to be testing on this?
Good question. My bigger concern is going to be the paper I'm going to have you write. So starting either today or tomorrow, I'm going to upload. What's today? Is today Wednesday? No, Thursday.
It's Thursday.
Today, I'm going to upload some math that I want you guys to work on. I'm going to make due Monday. We will go over the math on Monday. And then after that, I'm going to assign a writing assignment. All right. The writing assignment is going to be a bigger chunk of assessment for this. When I do assess, it will probably be only 15 multiple choice questions and 1 free response. Okay. Again, if you did not pass the last test, I sent you an email today going over how to get on to the retake. The retake is 15 questions, and you have to use the Illuminate Lockdown browser to get on it. Okay. If you have questions about that, I encourage you to email me separately, though. All right. I'm going to end my recording here. Because I don't need it anymore.